Who knows Uber? Everybody. Who has used Uber? Almost everybody. Who has used some of those red new bikes in the city? A few. Impressed. Who knows Careem? Half. That's good. When I was introduced to Careem, I didn't have any clue, I must admit. And I was super surprised and excited to learn what Careem actually are, right? So they are what we would think of Uber in the US or in European markets. That's what Careem is actually in the Middle East, Asia, and Africa. I think I was told in Dubai, 80% brand awareness. Like 80% in Dubai know what Careem is. So that's amazing. And yeah, and Uber just acquired Careem recently for 3.1 billion US dollars. So you can imagine it's not just a startup. So it's a real big company. And hence, I'm super happy to have actually Ahmed Kamal coming over from Dubai to Berlin. Not just out of a reason to speak at AI Monday, but also Careem has an office here in Berlin. They actually have a development team and are looking for a bright talent. And so if you're interested to work for Careem, get in touch with Kamal or the team that is here later on. And so handing over to Kamal, big applause.
Hi, everyone. So thank you so much for having me today. I'm really happy to be today in Berlin to speak to all of you about how we are scaling machine learning in Careem. Just to correct something, it's not 2.1, it's 3.1 actually. So let me first introduce myself. I'm the machine learning platform lead at Careem, where we are trying to build an in-house machine learning platform to make machine learning development and productionization very easy and very smooth. So you can find me plugging here, and you can also find me on Twitter. And today, I will be representing my team and the amazing work they have been doing for the last period. So who are we? Careem has started in 2012 in Dubai, UAE, with the mission to simplify the lives of people and build an organization that inspires. We are operating in 15 countries, 120 cities, and with more than 30 million customers and 1 million captain, we are the largest multi-vertical platform of mobility, delivery, and payment. Careem had started as a business booking service. We transitioned to be a ride-hailing company, and we are now the leading technology platform in the Middle East. So basically, if I'm in the Middle East, I wouldn't have included these slides at all. So with this great power comes a great responsibility to provide wowing experiences to all of our customers. And this can only happen through data. And if you want to do this in a scalable way, there is only one way to do it, through machine learning and AI. So let me take you in a journey through our different machine learning and AI use cases. The first area where we are using machine learning is our marketplace, where we are targeting the optimization of our different components. We are basically trying to balance between demand and supply. This is very important for our peak, dynamic pricing, and also smart dispatching. The second area is actually to enable us to fulfill our promise to customers and captains. Yes, we call our drivers captains. So we do this through offering accurate ETAs, accurate prices, and we are also using machine learning to understand our customers and captain behaviors. So you can easily see some applications like cancellation prediction, captain acceptance prediction. One more area where we are extensively using machine learning is platform integrity. And this actually means some topics like fraud prevention, detection, and also anomaly detection. So let me give you a very small example of how we are leveraging AI and machine learning. Here we have one captain and one customer. So it really seems to be very easy to assign this captain to this customer, right? But once we have one more customer, things start to become a bit tricky. So should we dispatch this captain to Mariam or to Rashid? With a 6-minute ETA, it makes a bit of sense to dispatch our captain to Mariam, right? But once we have more information, like the probability of cancellation for our first customer and second customer, it starts to become a bit actually different. Here, it may be wiser to dispatch our captain to Rashid. With a probability of cancellation of only 10%, it makes sense to give him our captain. This is actually one of the other applications we are really depending on Careem. With time series forecasting, we are able to predict the demand in a big city like Cairo. And here on the right side, you can see our algorithms predicting the demand in Cairo versus the reality. And the reason why we are able to get such an accurate results is due to the huge amount we are storing and collecting from our customers and captains. So let me invite you in a journey to be one of the data scientists in Careem till the rest of this session. So you just joined Careem, you are doing your onboarding, and you are enjoying the sunny view over the longest building in Dubai, and the world, actually. And you just got assigned your first problem. We want you to predict the estimated time arrival of a captain for a specific booking. This might seem like an easy problem, right? Let's just use one regression technique, super easy. So let's do it together. We are looking now at our dataset sample, where we have the user ID, the car type, whether it's business, economy, or even a bike. We have captain information and booking also location. And now we are ready to do and develop our first model. So this is the traditional machine learning development workflow perceived by a lot of us. You get your data, done. We have modeling, OK, we will do it. And then we train a model, store it, and that's it. Is this really all what it takes to build an AI experience in Careem? Let's see. Machine learning in real world is really different than what's really perceived by a lot of data enthusiasts. In real world, you have a lot of challenges to care about. Let's try to brainstorm some of them. First thing is data size. Our data is huge. And in a company like Careem, we have millions and millions of bookings. And this could mean that you might use terabytes of data just to train and develop your model. This also means that you need a lot of resources in order to be able to do feature engineering, training your model, especially if your algorithm is a bit complex and you need to do a lot of iterations. You also need this to be in production, right? What does this mean? It means we need to build an API. This API has to offer low latency. We care about customers, and we care about this experience. We also need to handle high throughput. And when we say an API, we mean a production-level API, which means monitoring, alerting, fault tolerance, and auto-scaling. So now, the model that actually was expected to be developed and deployed in 1 or 2 days might take a week, couple of weeks, right? And also, a lot of the skills that are needed are totally outside of the skill set of you as a data scientist, right? So we might get a data engineer, machine learning engineer. So now we have a team. And this team needs a couple of weeks just to develop one use case. So fine, it's your first project, and we want to actually help you succeed. We gave you all the resources, and now we have your model done. Your model is amazing, and everyone is loving it. But it was just deployed in one city, and we need to deploy this model in the rest of the 120 cities in Careem. So good luck with the next steps, right? First, we need to continuously refresh and update all of these different models, because we have a dynamic market, and the model that's working right now might not be really the model you want to have in production after a couple of weeks. You also have something in production, right? So production means monitoring. And once you have something in production, you also need to be aware of how it's performing, which is why we need alerting. We also need to A/B test. Whether to A/B test between the old model and the new model, maybe a retrained one, right? Or maybe to compare between two new approaches that are solving the same problem. But is really machine learning the solution for everything? Sometimes it's not, especially if we are just entering a new city and we have very low amount of data. So that's why it might make sense to use some other approaches in that case. What about the rest of the 100 cities where we have a lot of data? You need to develop different models to train all of them. And sometimes, actually, the model that you just developed won't be the same model that you will use in these other cities. So it could be as easy as you will just do a hyper-tuning, or maybe you will need to change the whole approach and do it fully differently. So we have all these models, but still we didn't deploy them. And now you have actually to decide whether you want to have an API for every model, which means 100 APIs, really, too many, or you want to basically couple them all in one service. And how are you going to handle the integration headache between all of these different APIs and your production environment, which is so critical all the time? So as we can really see, modeling is not really the biggest effort that you need to do in order to build an AI use case in a company with the scale of Careem. So if you see here, machine learning code is just a tiny piece of what you need to do. You need to do a lot of other things, starting from configuration, feature extraction, data collection, analysis, serving, monitoring, and who will do this? We need a lot of people just to do this. And that's why we decided to invest in building our own in-house machine learning platform. We call it Yoda. So Yoda is basically aiming to automate the end-to-end experience of building machine learning. We aim to accelerate the adoption of AI in the whole different domains of Careem by building Yoda in order to enable the expeditious development and deployment of thousands of models in production. So what would your life look like after using Yoda? First, for dataset generation, you can just provide a SQL query. We will run it for you on our Hadoop infrastructure, and you can get your dataset in a very scalable way in no time. You can even use our feature store, get some features from this centralized data store, and start modeling from day one. You have your dataset. It's time to train your model, right? And what is the most interesting and cool tool that all the data scientists are using every day? Jupyter Notebook, right? So we have an integration for Jupyter Notebook with Yoda, where you can just use a Python package, which is balancing between the ease of use and the readiness for production. You can write your algorithm using this package while accessing all the different and famous machine learning libraries, whether it's XGBoost, CatBoost, scikit-learn, or even Spark. Given some configuration that you need to provide, you can train your own model. And once you have a model, you also have an evaluation report. And the reason why evaluation is so important is when you have machine learning in production, it's not just about using machine learning. It's about using machine learning to deliver value. And that's why we invested a lot of time and effort in order to offer our data scientists with a lot of visualizations, cool metrics, and different ways to measure the impact of the work they are doing. So it starts from our UI and also goes through Slack and different other sources. You got your model. Congratulations. Now you need to deploy it. But rather than spending weeks and weeks like talking and coordinating and communicating with different teams, you can just use our one-click deployment service to deploy your models in a couple of minutes. You just provide configurations, and then you click, you get an API. And it's not just an API. It's a production-level API, which means it's passing our latency, integration, and different API tests. And once you have it, you can just integrate it into your service from day one to have your AI experience delivering value as soon as possible. We also offer other features like auto rollout, where your model can get updated, deployed automatically with no human intervention. So now you have an API, you can send a request, receive a response, it's production level, that's it. So this is like a summary of Yoda. We are covering the different stages of machine learning, as you can see, starting from dataset generation, training, dimension readiness detection, which basically is which city is ready for our models, and serving. And our vision for Yoda doesn't really stop here. We are aiming to enrich our feature store and to include and encourage our different data scientists to add and contribute thousands of features, which mean that we can easily allow our data scientists to use features that we collected from our food app in our ride-hailing business, or from our ride-hailing experiences into our payment engine. We also really believe in AutoML, and we are betting heavily on it, because we believe that AutoML is really the future of accelerating the adoption of machine learning across big companies like Careem. We also believe that AI is not just for tech and data scientists, right? So we need to enable everyone in the company to use machine learning. And this starts from building these custom platforms that enables everyone to do time series forecasting, anomaly detection, and to deal with text, basically using natural language processing. So with this actually slide, I have wrapped up what I have for today. Thank you so much for listening. You can reach out to me on Twitter for the slides, and I hand it over to Jury. Oh, I think if you have questions, right, first?
Exactly. So
Yeah.
it's now time for applause first. Thanks so much. Very good.
Yeah.
And I'm sure there's some questions to Kamal.
Thank you for the talk. First, so you mentioned model evaluation. So do you mean like performance evaluation or also functional evaluation? And if it is only functional evaluation, how do you guarantee production level APIs if you don't test performance?
OK, that's a great question, actually. Thank you. So actually, we do both, actually. Like, performance evaluation is there in order to make sure that the model is accurate and we allow our data scientists to basically set some SLAs for the performance of the model itself. So it depends whether you are doing classification, regression. There are like famous metrics for each of them. You can just code like the validation logic for the performance of your model, and this will be integrated into our pipelines automatically. Even speaking of the production integration, this is also happening. And I just mentioned in the last slide that once you build an API in our one-click deployment service, we make sure that we do integration tests, that we do stress testing, and we make sure that this API is really ready for production.
Kamal, how much people do you have that work on machine learning at Careem?
Actually, we have 6 amazing colleagues. And we have been working actually, like, I think we didn't really reach 6 until very recent time, but we have been working since 2 years on this. On the platform, yeah, just the platform, yeah.
I was just asking. All right, any more? Oh, there's one. Otherwise, make sure you catch Kamal later on.
Hi. Great talk. My question is, what are some of the things that you learned as you are building this in terms of making assumptions and then those assumptions turn out to be wrong, and how you guys have adapted for future requirements?
Yeah, thank you. So I think actually the biggest learning here is that machine learning is still seeing the same progress that software engineering has seen actually in maybe like the 2000s era. So basically, a lot of the practices that are very, very famous and widely adopted in software engineering are very lacking in machine learning. You can think about something like versioning, for example. For software engineers, versioning is like de facto. Like, everyone does it. Like, everyone uses Git. But if you are talking about model versioning, not really a lot of people are thinking about doing this, right? If you are thinking about building like APIs and like latency, performance, all of these different aspects, there are already a lot of standards in the industry for software engineering. But when people think about machine learning, you don't really see this part. And that's why there's this new common name called machine learning engineering. Requirements and features, right? This is also very tricky, because you are building a product for data scientists. And that's why you need to put yourself in in the place of a data scientist, try to understand, listen to him, and try to collect feedback. This has been a very continuous process. We went through different iterations. We didn't start from this stage. We started very, very small with an MVP, and we continued iterations, listening, until we reached this stage.
Good. Then another applause for Kamal.
Thank you so much.